Okay, so this whole unit is all about sequences, series, and probability. So it's kind of a little bit of everything. If I asked you what a sequence is, could you give me an example of a sequence of numbers? 1, 2, 3, 4. That's a great sequence. You just add 1 every time. What's another sequence? 2, 4, 6, 8. I knew you guys were going to say that. What's another sequence?
3, 6, 9, 12.
7, 14, 21. That's timesing by, 7 plus 7 plus 7.
32.
Those are pretty good.
5, 10, 15, 20.
Yeah, so you guys know what sequences are, okay? They're a string of numbers, right? But specifically positive integers, okay, that we get based on a kind of formula that you're given, okay? Now, the notation that we've been using a lot is our function notation. Function notation is something like f of x, right? That's function notation. Sequence notation is usually denoted with a sub n, okay? Or maybe you'll see it with t sub n, okay? And this letter n is used instead of x, okay, as a reminder that n is always representing a natural number, not like a decimal, okay? And then the only other thing in there is that I want to talk about is the fact that we call the terms in the sequence A1, A2, A3, or A sub 1, A sub 2, A sub 3, okay? That's what you call each term in the sequence. So like the first term in the sequence is A sub 1. Second term is A sub 2. That's how you denote it. That's how I will know that your second term is 5 or your second term is 3, okay? All right, let's look at an example here. These first 3 pretty straightforward. It says write the first 5 terms of the sequence, okay? If I want to find the first term of the sequence, I'm going to let n equal 1. So it's just a sub 1 equals, plug in 1 where you see n. So I've got 1 plus 1 divided by 1 plus 2. We can simplify this, yeah? 1 plus 1, 2. 1 plus 2, 3. That's my first term in the sequence. My second term we would denote with a sub 2. And I'm going to plug 2 in for n. So 2 plus 1 over 2 plus 2, which would be 3 over 4. Okay? I do not expect you to show your work every single time. Because do you think you could probably figure out these other 3 terms just by, plugging it in your head? Yeah, and that's okay. Okay? You do not need to show me the work for this, but go ahead and fill out what is a sub 3, a sub 4, and a sub 5. What are the third, fourth, and fifth terms of this sequence here? So we should have gotten 4 fifths, 5 sixths, 6 sevenths, yes?
Yeah.
Perfect. Okay, so that's exactly what these next 2 examples are as well. It's just given a different sequence that you're plugging it into, okay? This sequence for B is saying I'm taking -1 to whatever power, whatever term I have, and then I'm timesing that by n, whatever term I'm on, okay? So the first term, a sub 1, I'd have -1 to the first power times 1, which would end up giving me -1. A sub 2, I'm going to plug in 2 where I see n. And if I simplify this, -1 squared would be 1 times 2 is 2. Okay. Continue this all the way up to a sub 5. We should get -3, 4, and -5. Okay. Each term here is changing between negative and positive, right? Okay. One thing to note is when we are talking about like writing formulas in the future classes that we're going to be in, this -1n notation allows us to kind of flip-flop between even and odds. Not even and odds, but positive and negative. Okay. So this kind of flips between positive and negative values. Okay? All right, and last one here, we're just plugging in some values again, finding the first 5 terms. So I'd plug in 1 for my first term. I get -1 to the first power over 2 to the first power, which just gives me 1 over 2. Again, this -1 to the n, if you see that kind of notation, what's happening between each term? It's going from, oh wait, that should be a negative. Sorry. No wonder you guys were looking at me like I'm crazy. So you switch between a negative and a positive again, right, is what's happening. So go ahead and find the rest of your 4 terms here. And check with your neighbor, see if you got the same thing. Perfect. So that's like the first page of your homework. Okay, there's like 6 or 7 questions. All you're going to do is just kind of plug in some numbers, figure out what the first 5 terms are. Okay, not too terribly complicated there. Now, the next thing we're going to talk about is sequences. Well, no, there's still sequences, but it's using a different kind of definition. It's not using that same notation of a sub n equals n plus 5 over 2. It's going to be using the previous term. So we call that recursive sequences. Okay, it's the recursive definition of sequences, where it's using the previous term in order to simplify. Okay, so if I look at this example here, we're given a lot more information just other than a sub n equals something, right? We know that a sub 1 equals 4. So that's my first term. I already was given my first term. So now I need to only find 3 more terms. Okay, but my second equation that I'm given here is a sub n equals 2 times a sub n minus 1. What does that mean? What is a sub n minus 1? If I plugged in 2, I wanted to find my second term in the sequence. 2 minus 1, that would give me 1. So a sub 1 is what here in this case? 4, right? So it's using that previous term. So this notation right here is your previous term. A sub n minus 1 is taking the previous term and plugging it in there. Okay?
How do you know that it's...
Okay, so what I would do is I would write A2 is equal to 2 times, I'm going to write this out. You don't have to do that every time, but just to show us kind of what's happening here, so that you know where it's coming from, okay? So I just plugged in 2 for n, which if I simplify this, I get 2 times a sub 1 plus 1. And I know what a sub 1 equals. It equals 4, so I can plug that in. So I get 2 times 4 plus 1, which gives me 9. Okay, so a sub 2 is 9, or the second term in my sequence is 9. Third term in my sequence, I'm going to plug in 3 where I see n, so I've got 2 times a sub 3 minus 1 plus 1, which means I have 2 times a sub what? A sub 2 plus 1. Well, we know what a sub 2 is. What's a sub 2? 9, right? So I'm going to plug in 9 for a sub 2. To give me 19. Okay. Go ahead and find the fourth term for me of this sequence. You're going to have to use the previous term to evaluate it. Do we all get 13? Or 39, sorry? Yes? Okay, good. All right. Well, let's look at this second example here. Okay, same idea, just different recursive equation here. So I've got a1 equals 2, so I've already got my first term in my sequence, and I need 4 terms. Now my equation over here says that I'm taking my previous term, I'm adding n to that, and then I'm subtracting 1. Okay, so if I was looking at a sub 2, if I plug in 2 where I see n, I have a sub 2 minus 1 plus 2 minus 1, which is the same as a sub 1 plus 2 minus 1. And we know what a sub 1 equals, 2. So I can plug that in. So I get 2 plus 2 minus 1, which gives me 3, right? Okay, go ahead and find the third and the fourth term of this sequence. If you're not sure, ask your neighbor or ask me and I can help you. Did we all get 5 and 8?
Yes.
Perfect, okay. So that is some examples of recursive sequencing, okay, using a recursive definition to figure out what our terms are going to be in our sequence, okay? How many of us have heard the word Fibonacci sequence before? Yes, very good. Huh? Oh, you're trying to find him online. So one of the most famous sequences in math was discovered by Leonardo Fibonacci, okay? I do not know his middle name. What is it? Pisano. Interesting.
Yeah.
Okay. It shows up a lot in nature. Okay. If you just Google Fibonacci sequence, it'll show you a bunch of different pictures of things in nature that basically use a Fibonacci sequence. But here's what the sequence is. It's 1, 1, 2, 3, 5, 8. That should be a comma. 13, 21, 34, and 55. So I want you guys to try right now writing a sequence rule for this series. Okay, try and figure out what's happening between the numbers to get the numbers. If you had to figure out what the next 3 numbers is, what would you do? Okay, try that out for a minute or two and then we'll go over what the answer would be. Okay, the idea behind it is that you're adding 1 plus 1 to give you 2. You're adding 1 plus 2 to give you 3, right? You're adding the previous 2 terms together to give you the next term in the sequence. So if I wanted to write that out with an a sub n, the previous term we denote with a sub what?
1.
A sub, not just 1, and minus 1. And then the next previous term, 2 terms before that, this is the first term before. The second term before would be a sub
N minus 2.
and minus 2. Okay?
I got it.
That's amazing. But is this all that I'm given to figure out my sequence?
No.
No, because otherwise, I don't know what a sub n minus 1, I don't know what any of those numbers are. So we need to be at least given some of these things, right? So if I knew that a sub 1 is 1 and a sub 2 is 1, could I figure out any term after that?
Yeah.
Yes. Okay. So this would be sufficient enough using your recursive definition for sequencing in order to find the Fibonacci sequence. Okay? So today is focusing more on evaluating these sequences and series and things and summations. The next class is going to be we need to kind of write an equation for the sequence that we're given. Okay? So moving on to the next page. We talked about we talked about sequences. Now we're talking about series. A series is the sum of terms in a sequence. Okay, so we're adding all these terms together in our sequence, and we write that in summation notation. Okay? There's 2 different series that you could find. You can find either a finite or an infinite series. A finite means it stops 1 to 5. I want to add the first 5 terms of the sequence together. Infinite, I think, speaks for itself. I'm going to go from 1 to infinity, however many terms in my sequence, add those all together, what do I get? Okay? Now, 2 other things here is this little symbol right there looks like an E. Anyone know what that is? It's a Greek letter. Starts with an S. Sigma. And then we call this down on the bottom, I equals 1. That is my index. Okay? My index tells me what number I'm starting at. Okay? So I'm going to say starting number. This N on top, that tells me where we are stopping. Okay? That's our stopping number. Okay? So let's look at this in terms of an example here. It says evaluate the series. And when I say this, like, I would say the summation, right? If I was, like, saying this out, this would be, like, the summation of our sequence here, which is 2k plus 1, from, I'm starting down here at 1, and I'm going up to 6. So the summation of 2 to the k plus 1 from, what was it, 6? No, 1 to 6. So that means I'm going to plug in 1, I'm going to plug in 2, I'm going to plug in 3, plug in 4, plug in 5, plug in 6, and add all of those terms together, okay? So my first term is 2 to the 1 plus 1. That's my first term. I'm going to add that with my second term, which would just be 2 squared plus 1. My third term would be 2 cubed plus 1. Fourth term is 2 to the 4th plus 1. Fifth term, and sixth term. Okay. Now, on your guys' quizzes and tests, you'll be able to use a calculator. Okay. With that being said, I would like to at least see, like, you write out this first step. Okay. Because then if you just get like a calculator error plugging it in, I can still give you some partial credit. Okay. Because I can't see what you typed into the calculator. Sound fair? Okay. So go ahead and plug this in. I want to make sure we are all getting the same answer. You should end up getting 132. So plug that in your calculator real quick and see if you get 132. Okay, these next examples, we're doing the same thing. Always evaluate it if you can. Okay, this first one though, we're not going to be able to evaluate. Where am I starting at? 3. Okay, starting at 3, I'm going up to 6. Okay, this letter could always change. It could be J, it could be X, it could be N, it could be D. It doesn't matter. Okay, but wherever I see this letter, I'm going to plug in my numbers. So I'm starting with 3, so A sub 3. Then I go up to 4. A sub 4. All the way up to 6. Can I do anything else? No, that's just it. We're done. Okay? We evaluated what we could. Now we move on. Okay, this next one looks a little bit more complicated because we've got some other stuff going on over here. Okay? Ignore that other stuff for now. Let's just write out what am I adding together. Okay, where am I starting at for this summation? 1, and I'm going up to 3. So I've got 6x sub 1 minus 2. That's my first term. Bless you. Plus my second term, 6x sub 2 minus 2. And then my third term is 6x to the third, or x sub 3 minus 2. Okay, and then just what he was saying there, we know what x sub 1 is, we know what x sub 2 is, and we know what x sub 3 is, right? So I can plug in all of those values and evaluate. I've got 6 times 2 minus 2 plus 6 times 4 minus 2 plus 6 times 6 minus 2. And then either evaluate this by hand or using your calculator. Either way, you should end up getting 66 for your answer. All right, I want you guys to at least ignore kind of all this other stuff here for a second, okay? Using your sigma notation, using your summation notation, how would I write the summation of this series, okay? Try and write that out for me.
Oh, there's a triangle. This sucks.
There's a triangle, but don't freak out. Yeah, the triangle does stand for delta. Okay, so this is what you should have gotten after you just separated your summation, right, of your series. And now we got to plug in all the stuff that we know up here, okay? All of my x sub 1s, x sub 2s, x sub 3, x sub 4, we know values for those. And their delta x there is 2. So if I plug all that information in, I have f of 0 times 2 plus f of 2 times 2 plus f of, 4 times 2 plus f of 6 times 2. So when I evaluate this, is it just like f of 0 times 2 is 0 or what? Are you sure? So in this case it will, right? Because when I plug in 0 to my function f of x, 0 squared times 2, that does go away, right? But f of 2 times 2 is not just 4, right? I got to plug in 2 to my function. So I get 2 squared times 2. I plug in now 4 for my function. I get 4 squared times 2. And then I plug in 6. I get 6 squared times 2. And now I can just go ahead and simplify this stuff out. Okay, go ahead and plug this in your calculator or evaluate it by hand. And we should get 112. Got it? Okay, so these are those 6 properties that are going to be on your property sheet that you will have on your quizzes and tests in this section, okay? To help you guys figure out when we're solving these problems below, I'm going to label these as 1 through 7 so you see where I'm getting the formulas from so you can go back and look if you're confused, okay? Okay, so the only notation that you got to know is that A sub 1 through A sub n is a sequence, B sub 1 through B sub n is a sequence, and C is a constant. What is an example of a constant? 1. Okay, it's any number, right? Not a decimal, whole number, okay? But if those two things are true, okay, then these summation properties hold true. Okay, so basically what's happening, this first one, C is a constant. So if you just have a constant there, you would take and multiply your number on top with your constant, and that's your answer. I'll kind of show you that here in a second when we do our first example. A lot of these properties can be figured out, like you guys can discover them, but we just don't have time for you guys to discover them, so we just need you guys to be able to know how to use them, okay? The second one here says if I have a constant times a sequence, I can take that constant out front, figure out what is the summation of my sequence first, and then just multiply it by whatever my constant is. Okay, if I have the summation of 2 sequences added together, I can separate them and simplify them individually and then add those together, and that would be my answer. Same thing for the subtraction, except for on the subtraction, notice that there's not a negative in front of the B. It's a minus sign in between, right? And these last 3 are where you're like, where did those come from, okay? Again, these are all things that you could discover if we had enough time, but for the time being in this class, if you see something like this says I, but really it's like a variable, pretend it's like x. If you have an x there, or if it's like x squared, it's any number or any letter squared, okay, or any letter cubed, this is what you're going to end up with over on the right-hand side of your summation, okay? So all you're going to do is plug in the n value, that top number, into these formulas to simplify what your summation would be, okay? All right, let's look at some examples here. again, I'm going to show what property I'm using right next to it. So this first one here, I've got the summation from 1 to 40 of 5. If I was just evaluating this, like you could do this by hand. Like 5 plus 5 plus 5. That's my first term, second term, third term. I'd go all the way up to my 40th term, which would still be 5. So do you guys see why we can take 40 times 5 to give me our answer of 200? If I added all of those 5 together, so I would get 200. That is using property 1, which is a constant. You multiply that top number with your constant to get your answer. Okay. All right, example B. Okay, again, I don't love that they chose I in this because technically I is an actual number in math, isn't it? Yeah? But if it's in this notation, we assume that this I we're plugging in for to figure out what my summation is going to be, okay? If I've got 2 times I, there's 2 properties that we're going to have to use. What 2 properties do you think we're going to have to use from up above? Number 2, because I've got a constant times a series, and not quite number 1. Let's take out the 2 first. So this is using property number 2. I could rewrite this as 2 times the summation from 1 to 22 of I. Now, what does this look like? Which property does that look like up above? Number 5, right? Because it just has an I there. So this would be property number 5. I still have that 2 out front. And then looking at property number 5, it says n times n plus 1. Well, n is what in this case? 22. So I've got times 22 times 22 plus 1, because it's 22, or it's n plus 1, and then divided by 2. That is from my formula up above. So now I can simplify this. Those 2's go away, and I'm left with 22 times 23, which ends up giving me 506. Okay, 2 more examples here. We've got like 4 properties, I think, that we're going to use on this one. Okay? First one, anytime there's addition or subtraction, I want to split that up. So this is now going to become the summation from 1 to 14 of 2i squared minus the summation of 1 to 14 of 3. Not negative 3, just of 3. Which property did I just use? Property 4. Okay, that first term there is very similar to the one that we just had, right? What property would I need to use first in order to evaluate this? I see a 2 and I see a 5. Both of those are right, okay? Let's first start by moving out the 2. So property 2 says that if I have a constant times a series, I can take that constant out front, right? And if you guys were just doing this on your own, you might, simplify these things a little quicker or a little different, and that's okay, as long as you end up getting the same answer here. Because technically, can I simplify this piece now? Yeah, and I can now actually use the property up above and simplify this one. So to simplify my I squared series, or like if it was x squared, okay, that's going to be using property number 6. Okay, property number 6 gives us a formula, which you don't have to memorize, but you need to be able to use. So I've got 2, and I'm multiplying that by my n, which is 14, times 14 plus 1, times 2 times 14 plus 1. It's n times n plus 1 times 2n plus 1. And And then it's all being divided by 6. Okay, what property do I use to simplify that second summation? Yeah, the 3 plus 3 plus 3, which is property number 1, right? So I can go ahead and say that this is 3 times 14, right? Okay, and now we can go ahead and simplify some stuff. I would first maybe do this. So I'd have 14 times 15 times, let's see, that would be 29 divided by 3. This would give me 42. And then I would type that into my calculator. Now, if you remember, if you type in on your calculator alpha, y equals, it creates a fraction for you, okay? So that you make less mistakes when you're dividing. Because order of operations says, I want to multiply this whole top before I divide by 3. And then I'm going to subtract 42, okay? You should end up getting 1988. Go ahead and plug that in your calculator. Make sure you get 1988. Okay, I want you guys to try splitting it up using the properties up above. How would I rewrite this and simplify? Okay, I'm going to give you guys maybe 2 or 3 minutes here to try it out yourselves, and then I will kind of show what I would do if I was solving this. Looks like all of us did at least the first step correct. Splitting it up. And then each of these properties are up above. This first one is going to use property what? I squared.
No,
6, yes, property 6. And I would rewrite with my n equals on top. I've got 6 times 6 plus 1 times 6 times 2 plus 1, all divided by 6. Using that formula. For this second one here, did we take that 3 out in front? Okay. If I take that 3 out in front, that's using property what? Property 2. Okay, and then could I simplify this third one using a property? If I just have a constant? Yeah, this would be plus 5 times 6 using property 1. Okay, so now the only one we got to go back in there and simplify using my formula is that piece there in the middle. So which property would I use to simplify that one from above? Property 5. So, yeah, we got to make sure we don't forget the 3. Thank you. So I'm going to simplify this. 6's go away. I've left with 7 times 13. Then I've got plus 3 times. Don't forget that 3. Our formula is n, which is 6. So 6 times 6 plus 1. All divided by 2. And then we can add 30 to that. And if I simplify all of this stuff and plug it in my calculator, you should get 184. Okay? Questions on this one?